Good morning to everyone. Welcome to today's session. I think every one of you understood what all we have seen so far in the last video. And today also we are going to continue the same lesson. And I hope every one of you understood different kind of problems under probability. So today we are going to see the last exercise of your topic, that is 15.2. So that is your optional exercise. So in every lesson optional exercise is there, but in book they mentioned that it is not an exam point of view. But so some of the questions they are asking in examination, in board examination, so that it is very important. So today we are going to discuss the sums under that optional exercise, right? So before going to today's session, let us recall the definition of probability and some properties also. So the probability of an event E defined by the number of favorable cases of an event divided by total number of cases, and in notation it is denoted by n of A divided by n of S. So n of A is nothing but number of favorable cases and n of S is number of sample space, right? And before going to solve any probability sums, we need the total number of space, that is number of sample space and also number of favorable events. Next, properties. So three important properties are available in probability, that is sum of the probabilities of all events of an experiment is 1. For example, while you are tossing a coin, the probability of getting head is 1 by 2, the probability of getting tail also 1 by 2. If you add these two means we'll get 1. Similarly, when rolling a die, the probability of getting a number 1 is 1 by 6, the probability of getting the number 2 is 1 by 6, and similarly the probability number 6 is 1 by 6, and if you add everything you get 1 only. So that is comes under the formula P of E plus P of E bar equal to 1. So E bar is nothing but the complement of E, the opposite set of E, okay. And then next, if an event it is not possible to occur in such a place or any place, that is called impossible event. Suppose if you are rolling a die, the probability of getting the number 7, it is not at all possible, therefore the probability of that particular event is 0. So the probability of an impossible event is 0 always, so that the numerical limitation of the probability is 0 to 1. So the minimum value of the probability is 0 and the maximum value of the probability is 1 of an event, right? So these are the three important properties on probabilities, right? Let us enter into today's session. So optional exercise, look at the first question. So here two customers Shyam and Ekta are visiting a particular shop in the same week from Tuesday to Saturday, right? Tuesday to Saturday. Each is equally likely to visit, okay, equally likely. In the last class we have discussed about the word equally likely. So equally likely means two events are said to be equally likely, means they have the same chances to be happened or to occur, okay, that is called equally likely events. For example, if you're tossing a coin, the possible outcomes are head and tail only. So the possibilities of getting head is 1 by 2, the possibilities of getting tail also 1 by 2. And also before finding the probability, when we tossing the coin, these two are the important, these two are the outcomes, and we don't know before itself which one will come first, okay. Therefore they have the equal chances to be happen, therefore they are called equally likely events. In the similar way, when you are rolling a die, so 6 numbers possible outcomes, but we don't know which number will come first and which number will come next, we don't know that case. Therefore these events, everything are called equally likely events, right? So here they are mentioned the equally likely, that is days as equally likely. That means all the days are treated as equal chances. That's it. Okay, they are visiting on from Tuesday to Saturday, right? So the question is, what is the probability? What is the probability that both will visit the shop on same day, consecutive day, and different days? Okay. So what is the probability getting on both are going on the same day, both going on the consecutive days, and both going on different days. Okay, we are going to find out the probability of these cases only. Okay, so look at the solution now. So this is your sample space. Okay, so here 5 days, that is Shyam is going to the shop on 5 days, and similarly Ekta also. So totally 5 into 5 equal to 25 days possible chances are here. Okay, so here the Wednesday to Tuesday, here this is mentioned that, so that Wednesday, that Ekta visiting the shop on Wednesday and Siam visiting the shop on Tuesday. And here Wednesday represents that both are visiting on same day. That is the meaning. Okay. So totally 25 possible cases arise, right? So that is your sample space. Look at the first question on the same day. Same day means how many same days are available? So both are visiting on the same days means Tuesday, and Wednesday, Thursday, Friday, Saturday. So how many possible events are there? So 1, here 2, and here 3, here 4, and here 5. Totally 5 days are there. So number of favorable cases nothing but 5. So the probability is nothing but 5 by 25. That is 5 here is number of favorable cases, and here 5 is nothing but total number of cases. So 1 by 5 if you after simplification. So next question is on consecutive days. So how many consecutive days are there? So consecutive means continuous day. Okay. So Tuesday, Wednesday, they are consecutive. And Wednesday, Thursday, consecutive. Thursday, Friday, consecutive. And Friday, Saturday, also consecutive. In reverse case also we can take. That is Saturday, Friday, Thursday. So like that. The order here not mentioned, so that you can take. Here Tuesday, Wednesday. So first one. And Wednesday, Tuesday, it is in the reverse case, you can consider this one also, and Wednesday, Thursday, and here Thursday, Wednesday, and here Thursday, Friday, and here Friday, Thursday, and Friday, Saturday, and Saturday, Friday. So how many events are available here? How many events we counted here now? So here 1, 2, 3, 4, 5, 6, 7, 8. So 8. So 8 is nothing but number of possible outcomes. The total space is 25. So the answer is 8 by 25. Right? And look at the next one. They both visited on different days. Okay. So different days. Totally 25 days are there. Out of that, how many days are same? 5 days are same day. So if we subtract this 5 from all the 25 days, we'll get 20 days. These 20 days definitely will be different days. Here I calculated like this. I didn't count here. Or if you need to find out, means you can count except the same days. Except the same days means these same days only will come. Okay. That remaining adult 20. So these are the 20 days. That is the number of favorable cases. Therefore probability is 20 divided by 25. So after simplification, we get 4 by 5, right? So that is the possibilities or probabilities of the given subdivisions. Look at the next example. So a die is numbered in such a way that its faces show the number 1, 2, 2, 3, 3, and 6. Usually, the faces on the die are represented by different numbers, 1 to 6 numbers, 1, 2, 3, 4, 5 and 6. But here they are asking to take like this. Okay. Now these are the faces of the given die. Okay. Now it throws how many times? It throws 2 times. Okay. And the total score will be noted like this. Okay. And one table also given here. Right. So this is nothing but the numbers on the first throw, and similarly here the numbers on the second throw. They're asking to find out the total score, therefore we have to add both now. Okay, so like this. So 1 plus 1 2, and 1 plus 2 3, and again 1 plus 2 3, and 1 plus 3 4, and 1 plus 3 4, here again 1 plus 3 4, and 1 plus 6 7. So likewise, so we are going to fill up the empty spaces here. That is the first question. And second question, we are going to find out the subdivisions already given here. Okay, now fill up this box, empty boxes now. So 2 plus 1 here 3, and here 2 plus 2 down 4, and next 2 plus 2 here again 4, and 2 plus 3 here 5, and 2 plus 3 again down 5 already given, and 2 plus 6 here 8. So 8. So likewise we have to fill up the remaining boxes also. So do by yourself, right? Now look at the given questions. So what is the probability that the total is at least 6? Here at least 6 already given in as a third subdivision. So no need to consider here. Okay. So the 3 subdivisions only given here, even number and exactly the number 6 and at least 6. So let us see one by one now. Now after completed, you will get this table only. Okay, now from the table we are going to answer this. So first question is even number, right? So how many even numbers are there inside it? Just count it and write it. So here 1, 2 and 3, and similarly here 4 and 5, 6, 7, 8, 9, 10, 11, and this one 12, 13, 14, 15, 16, 17, 18. So totally 18 numbers are there as even numbers. So 18 by 36. 36 is the total value. Okay. After simplification, we get 1 by 2. Next, we are going to get exactly 6. So exactly 6 means look at the table. So these 4 numbers, that is 4 times only occurs exactly 6. Therefore, here 4. So the probability is 4 by 36. After simplification, we get 1 by 9. Okay. At last, finally, at least 6. Okay. At least 6 means minimum 6. That is the meaning. So we can include maximum whatever it is. Okay. So we are going to find out how many numbers are there from 6 to above 6. Okay. 6 and above 6. Okay. So here 1, that is 7. 1, and this is 2, and this is and 3, and here 4, and for 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, this one 14, and this one 15. So totally 15 numbers are available here, 6 and above 6. So 15 divided by 36. After simplification, we get 5 by 12. So this is the procedure to find out the probability of the given subdivisions. So let us continue from the next video.